Alright guys, so today we're going to be talking about the protection of our central nervous system. This is going to be a bit of a shorter video because although it is very important, it is not going to be as much to cover, or there's not going to be as much to cover. So let's just get started. So the first layer of protection, besides our bones, our skull bones, are our meninges. So our meninges are the three thin membranes that protect our brain and spinal cord from mechanical injury. It supports blood vessels, and it can also form a continuous cavity for cerebrospinal fluid to pass through. So the first of these three thin membranes is the dura mater, otherwise known as tough mother. That's what this translates to in Latin, and it's pretty interesting, so thought I'd toss it in there. But it is the outermost layer that surrounds and supports our dural sinuses, and our dural sinuses are these large channels that collect cerebrospinal fluid and deoxygenated blood to bring back into the lymphatic system in our heart. So the dura mater is also the thickest and most fibrous connective tissue in the three layers of our meninges. It has a double layered covering. There's the periosteum and the meningeal layer. So the periosteum is the part that's actually attached to our inner surface of the skull, and the meningeal layer is going to be attached to the outer covering of the brain. It's also known as the deeper dura mater. So again, those are the two layers of our dura mater. There's a gap in between them. So two structures our dura mater forms is the falx cerebri and the tentorium cerebelli. So the falx cerebri is a thick, deep connection that's responsible for separating our two hemispheres, and it holds our brain still during head movements. So if you're, for example, on a roller coaster or shaking your head no, or vibing to music or headbanging to metal, your brain has to be held still. How does it do so? Well, that's where the falx cerebri comes into play. It's this very thick dura mater layer that really holds our brain still, kind of anchors it into place. We've also got the tentorium cerebelli, where it separates the occipital and our temporal lobe from the cerebellum and the brainstem. This is so the inferior portions of our brain, the cerebellum and the brainstem, aren't injured or weighted down with the pressure from above. So our brain's pretty heavy. I mean, it's 2.5 pounds, and all that pressure on our cerebellum and brainstem over time would damage it. So our tentorium cerebelli serves to alleviate some of that pressure and protect our inferior regions of the brain. So in the diagram I drew below, we've got the brain and we've got the falx cerebri. It's kind of hard to draw it, so I just drew it winding around the corpus callosum. And I also drew where the tentorium cerebri would be, or the cerebelli would be. Sorry, typo over there. So tentorium cerebelli and falx cerebri. The next layer is the arachnoid layer. This is translated to spider web because it looks very web-like. So this is the middle layer, and it supports the arteries and the veins of our CNS in the subarachnoid space. Now, your subarachnoid space is a CSF-filled cavity that contains all of our major cerebral arteries. The arachnoid villi are little projections that poke through the dura mater that allows CSF to drain out of the subarachnoid space into the dural sinuses. The most common is the superior sagittal sinus, and that's just where CSF will flow into and return back to the lymphatic system. But essentially, we've also got some web-like extensions that are spanning all throughout the subarachnoid space that attach to the pia mater. Now, usually, I really like to draw for my videos, and I feel like it's really fun for me, but for this chapter, I wanted to take some images out of my textbook in college because I found it to be super helpful. So I've highlighted the areas that I feel we've talked about. So I'm just going to talk through this diagram real quick. So we've got, again, starting with the falx cerebri, which we talked about earlier. It's this very thick layer that's in the middle of our brain that holds our brain still. And we've got the dura mater layer here. We've got our arachnoid layer here. So arachnoid layer right here, with the subarachnoid space all in here. So our subarachnoid space here is filled with cerebrospinal fluid, and it's for protection because our cerebrospinal fluid serves to kind of cushion and protect our nervous system or our central nervous system. So since there are a ton of major cerebral arteries here, there will be a lot of CSF. So we need the CSF to drain out because after it supplies nutrients, it needs to be circulated and there's more being secreted. We need CSF to drain out. It does so via these these arachnoid villi, which drain CSF out from the subarachnoid space into the superior sagittal sinus, which then goes through a whole another system, which drains it into the lymphatic system. Now, our pia mater is the third layer of our meninges, and this is known as the tender mother. That's because it's a direct translation from Latin, and it is the most internal layer that is the most thin and translucent. It really clings tightly to the surface of our brain and spinal cord. If you're ever dissecting or doing cadavers, you will sometimes be asked to identify the different layers of the meninges, and you'll notice the pia mater is kind of this very thin, plasticky feeling. It's attached to the brain and spinal cord. It's very tightly clinged. And the whole purpose of the pia mater is to supply nutrients to the surrounding nerve tissue. It's got a rich supply of blood vessels that are branching off, and it just provides a lot of nutrients to these regions. So those are the three layers of our meninges, and the first layer of protection besides the bones. Now, another layer of protection is our cerebrospinal fluid. So the CSF protects our brain and spinal cord from trauma, it supplies nutrients, and it removes waste products. It is basically the fluid of life. It's like the fountain of youth for our brain. It really does everything and helps our brain survive. Our brain is basically floating in a container of cerebrospinal fluid just for buoyancy and for protection, and we need to continuously circulate it and create more. How is more created? Well, it's created from the choroid plexus cells. We talked a bit about these in previous videos, but the choroid plexus cells are going to be located in each of the major ventricles of the brain. Now, if you see here, I was supposed to hand draw this, but I decided against it because, number one, I cannot draw this. I'm a terrible artist, honestly, and I want y'all to get the best understanding of our brain and the ventricular system. So again, I brought a diagram from my college lectures that I thought really exemplified this. So I'm just going to be talking through it, and we're going to also talk about the CSF flow on the following page. So some of the primary structures to keep in mind for this diagram are the two lateral ventricles here, which I highlighted. We have one for each hemisphere, and they each have an anterior, posterior, and inferior horn. These are named locationally because they point forward. They point towards the frontal lobe, the temporal lobe, and the occipital lobe, or the temporal lobe, and then the occipital lobe. So the horns are named directionally. Anterior will be facing forward, inferior will be below, and posterior is towards the back. Now, there's also something called the septum pellucidum, and that separates the anterior and inferior horn. It's more of a locational thing, and it helps with function. Now, the whole point of the ventricular system is to secrete and organize the flow of CSF. Now, again, I'm supposed to hand draw this as well, but I'm a terrible artist, so I can't. Instead, I opted to label these just to showcase the best. I know it looks really old and it doesn't look that great, and I'm sorry, guys. I know you're used to me hand drawing everything, but I promise this is going to be one of the rare times I'm not doing that. So let's start with the flow of CSF circulation. So first of all, we've got the lateral ventricle, right? As you remember from here, the lateral ventricle is right here. This is a different view of the brain. Now, we're going to trace it together. So there are choroid plexuses in your lateral ventricle. The choroid plexus will secrete CSF, which will flow down your lateral ventricle, and it'll enter your third ventricle here through the interventricular foramen of Monroe. So, just to reiterate, The choroid plexus will secrete CSF into the lateral ventricle. The lateral ventricle will enter the third ventricle through the interventricular foramen of Monro. Now, if you follow this down, the third ventricle, via the cerebral aqueduct right here, will flow into the fourth ventricle. Now, from your fourth ventricle, there are 3 ways they can go. Your CSF can flow. Either your median aperture, which brings it more medially to the brain, which is towards the center. Your lateral aperture, which will bring it laterally, so towards outside, or further away from the center. Or your central canal, which will bring it down to your spinal cord. So if you look carefully, from your fourth ventricle, this junction point, their CSF can flow up into the center, can flow laterally, down here and up around laterally, or can go straight down through your spine. If it goes into your median or lateral apertures, it'll end up in the subarachnoid space, where it'll be protecting the cerebral arteries, and then it'll go back into the dural sinuses to be circulated and reused, or not reused, but reabsorbed into the body. If it goes into the central canal, it'll go to your spinal cord and away from the brain. Because the central canal serves to send CSF to protect and cushion the spinal cord. Cerebral spinal fluid is very important for protecting the central nervous system, and your brain and spinal cord are surrounded by CSF. So, to recap, we've got the meningeal layers, which are 3 membranes that support and protect your central nervous system while creating cavities for cerebrospinal fluid to flow into. We've got dura mater, also known as the tough mother, which is the tough outer layer that's separated into the periosteum. In the meningeal layer, it's got the falx cerebri and the tentorium cerebelli. We've also got the arachnoid layer, which is known as the web-like spider web structure, and it provides cushioning due to its fluid-filled web-like structure where CSF is flowing into. And we've got the pia mater, which is the delicate tender mother, which is that delicate innermost layer that is a nutrient supply. The next layer, or the next form of protection, is cerebrospinal fluid, which provides support, protection, and waste removal. And it's very important to understand, if you're taking anatomy, you need to understand the flow of cerebrospinal fluid, lateral ventricle to the third ventricle via the interventricular foramen of Monro. Your third ventricle goes into your fourth ventricle via the cerebral aqueduct, and your fourth ventricle will enter your median, lateral apertures, or your central canal. Your median and lateral apertures will feed into the subarachnoid space, where it'll protect the cerebral arteries, and your central canal will feed into the spinal cord to protect your spinal cord. So that's all I have for you all today for this video. I hope it was helpful, and I'll catch y'all later.